Photoluminescence spectra of color stones using the strong UV lamp, long wave UV lamp, and a special UV filter, and I acquire the spectra directly on this mapboard. So we can start with the natural spinel, orange spinel, natural, unheated, in this way, and exposure at 1 is enough, and I can do something better with exposure, maybe 3. I can obtain a clean spectra. You can see the organ pipes are very good, and I can also check the peaks very well. So it's a high quality spectra for this natural unheated spinel. Now I can check with the synthetic one, the blue one. Using always this filter to block, for blocking the first and second order interference from the lamp. So in this case, okay, the fluorescence here is very strong, should be red strong fluorescence, so I can see the difference of the synthetic spinel. Now I can try with corundum. Of course, ruby and sapphire, synthetic sapphire, natural sapphire are always the same. The spectra is the spectra of corundum, so the difference is only for acquiring the stone with a strong or weak fluorescence. So like in this case, the fluorescence is very strong, so I'm decreasing the exposure. But it's interesting here that I can find the doublet of corundum. Yes, here, like that, maybe. So I can see the doublet here at 692 and 693.7. Yes, correct. So I can try with another one. This time a rough natural ruby. This is a nice crystal. Also in this case, the spectral corundum we can find. Okay, we can see again the doublet here. Okay, 692, 693 something. And then I can test the blue sapphire, synthetic blue sapphire. But I tried also with the basaltic blue sapphire with a very weak fluorescence, and increasing the exposure I can find the perfect spectra. So in this case, okay, in this case the fluorescence is not so strong, so I need to increase the exposure, but anyway, it's obviously a corundum. I know it's a synthetic corundum. Okay, this is a good spectra, always with our tablet here. Okay, now with something different, with weak fluorescence, and not always is easy to find a good spectra for tanzanite. In this case is a medium good blue tanzanite. Yes, here I need to have a strong exposure like this, but I can recognize immediately the spectra of tanzanite. I wait just 1 minute for this acquisition. The spectra is not smoothed. Is I can smooth like this. Okay, it's not so strong, but anyway, I can definitely acquire this spectrum, and I can say it's a tanzanite. Now we can check with another blue stone, a natural kyanite. The fluorescence of this stone is not so strong. So in this case, I need again to increase the exposure. But you can see these two peaks are characteristics of natural kyanite. Blue kyanite, very similar to blue sapphire for the color. And then we can try with the emerald. In this case, we have the first one is a synthetic Malossi emerald. And okay, is a strong fluorescence, strong red fluorescence. And this is my best spectra. Here, interesting, this peak 683.5 nanometer. So I can check with another one. This time is a synthetic emerald from Byron. Okay, the peak is higher, 683.2.8 now, 682. And the last one is a natural emerald from Colombia with a very weak fluorescence. And you can see the 683.5 of the peak, and I can increase the exposure for spectrum more clean. Okay, 683. Okay, it's possible to test many stones, but the most important thing that the stone should be with a nice fluorescence.